Hello everyone, today I'm going to show you how to visualize nitrogen purging of a tank. Basically, um, before we really get into the visualization of this purging using Power BI, at first we need to understand the term of nitrogen purging of a tank. So basically, there are a few times at a chemical plant where you need to purge your tank with nitrogen. So for example, let's say you have shutdown of a tank and you have some maintenance work to do on it. So let's say the tank contains, flammable chemicals and would have flammable vapors in it. So ideally, before you would want to start any work on the tank, you have got to purge it with nitrogen to basically rid of all these flammable vapors. The reason why you need to rid of these flammable vapors is that if you have that flammable vapor inside the tank and it mixes with air and somebody introduces an ignition source, it's going to cause a possible explosion. And similarly, once you want to get that tank back running, so you would have to purge it again, to just ensure there's no air left in the tank so that when you store your flammable chemicals back, it's not gonna be create a potential explosive environment in which you have flammable chemical and also air, and once an ignition source is present, it's gonna cause a possible explosion. So basically, that is what nitrogen purging of a tank really means. Okay, so regarding this nitrogen purging, one of the most important calculations that you would have to make is that depending on the size of the tank that you have, how much nitrogen do you really have to purge your tank with? So you can actually calculate this by using a simple ideal gas law. So first you got to know the volume of the tank that you have in hand, and second would be how much pressure of nitrogen that you would want for it to reach inside the tank um, for it to be completely purged. In this case, like for example, the calculation that I've done in Excel. So this is basically a visualization of the purging of a 200 cubic meters of tank um, purged by nitrogen at normal conditions, which is at a pressure of 1.1 bar absolute and also a temperature of 20 degrees Celsius. So by having this data, I can basically use the ideal gas law to determine how much does this 200 cubic meters tank need nitrogen. So I have, as usual, PV equals to nRT. We're going to just assume the number of moles and temperature of nitrogen will just be constant or the same once it enters the tank. So we can just simply deduce that P1V1 will be equal to P2V2. So our P1 here is the pressure of our incoming nitrogen, and if we assume it at normal conditions, it's just gonna be at 0 bar gauge or 1.01 bar absolute. The volume of nitrogen required is the amount that we would want to calculate. P2 would be our pressure inside the tank after the nitrogen purging, or the final pressure of nitrogen, once it enters the tank. And also you would have the V2, which is the volume of tank, or you could say the final volume of nitrogen, because it's going to be a closed system. So once you purge nitrogen to the tank, the final volume will be the same as the volume of the tank. So we can just determine the volume of nitrogen required by taking P2 times V2 over P1. So in this case, if I were to achieve nitrogen pressure of 0.2 bar gauge inside the tank, if I were to get a pressure rise of 0.2 bar gauge inside the tank, that is at 200 cubic meters volume, and assuming that the nitrogen is at normal conditions, which is at 1.0 bar absolute, I would need roughly 239.6 meter cubes of nitrogen. So basically, now that I have this Excel template, I can just play around by just changing the pressure of nitrogen that I want, or I can also change this volume of tank, and this will just auto calculate. So every time I would just have to change either of these two, and I would get the volume of nitrogen that I require. So this looks easy, but I'm not sure if you feel the same way, but for me it looks very too, too wordy. You would ideally want to create something like a visual, possibly with slicers in which you can just move and adjust the volume of the tank and also the pressure of nitrogen inside the tank, and you would get automatically the volume of nitrogen that is required. So how can actually we accomplish this visual? So this is where Power BI comes in. We can basically set up a simple dashboard in which we have a slicer of the final pressure that we want. Secondly, a slicer of the volume of the tank that we want, and from there it will auto calculate the volume of nitrogen that is required. So today I'm going to show you how we can achieve that. Okay, so now I've switched to the Power BI desktop application. I've launched it from my desktop, and now we can start doing the visual. So once you open that, I'm just gonna go to home, and at first I'm just gonna upload an image of a tank because that would make our visual appear more appealing. So I'm just gonna go to image. So I've actually downloaded a few pictures of tanks. So yeah, these are all just from Google. So I'm just gonna pick this one because it's my favorite. Alright. So basically I'm just gonna make it slightly bigger. There we go. And then I'm just gonna add another image, which is the nitrogen line coming into the tank. So I've drawn up something quite simple in PowerPoint. It's basically just an arrow and also a text box. So I've combined them both. So I'm gonna save them as a picture. So let's put that as N2 supply. Oh, turns out I've already saved it, but I'm gonna save it again. So now that it's become an image, I'm gonna switch back to Power BI and call the image again. Alright, gonna pull it. There we go. So I'm just gonna properly adjust these line of nitrogen so that it goes smoothly on top of the tank. So as you can see here, I've put it at the normal conditions of 1.01 bar absolute and also a temperature of 20 degrees Celsius. Alright, so now we're gonna draw up our first I would say variable, which is the final pressure of nitrogen inside the tank. So we're gonna create a slicer that's gonna let us put in any input of the pressure rise that we can easily adjust. So the way to do this is to go on top of this and go to modeling. So I'm gonna use this what if function, which is called a new parameter. So just click on it. So once you click on this what if parameter, you're gonna have something of this this box. So for name, I'm just gonna change it to pressure rise. Pressure rise, or ideally you could call it final pressure of nitrogen. This is your choice. So I'm just gonna put it bar gauge as the unit. No, I think we better put it as bar absolute. So for the data type, let's make it a decimal number. So minimum, I would put it at a 0, and maximum, I would say it's probably just gonna be around, actually 20 is a good number. For the increment, let's put it at 0.1 and a default value of 0. So add slicer to this page, make sure it is checked, and press OK. Alright, once you've done that, you're gonna notice that this pressurized bar absolute has appeared on our fields pane, and basically gonna have two items. One is the pressurized bar absolute, which is the value of 0 to 20 bar absolute that we put in just now, and all are increments of 0.1, as you can see here. So this one, I'm gonna drag it here. Yeah, put here more nicely. And so you can see here that we have that bar pressurized from the value of 0 until a maximum of 20. If you scroll down to the last one, right? And all are increments of 0.1 because we've specified it to be like that. So this doesn't really look very attractive as a slicer. So what I'm going to do is I'm going to change it to a single value slicer. So to do that, I'm just going to go to this drop down, select a single value. Alright, so now you have something of this box in which you can really adjust and it will show the pressurize that you want. So let's say I want a pressurize of 5, so I'm just going to drag it at 5. Okay, it's 5.1, but you can change it, just put it 5 here and it will appear as 5. So we have our first parameter of 5 bar absolute. So this is our first variable. So from the Excel, if you can remember, other than the pressure rise that we want, the second item that we ideally would want would be the volume of nitrogen. So we're just gonna do the same thing, but this time with tank volume. Okay, go to new parameter again, and this thing will pop out. So I'm gonna choose tank volume. So data type, let's just make it a whole number, minimum of 0, and maximum, I would say for now, let's just put 1000 cubic meters. Or probably 5000. Let's have an increment of 1 and a default value of 0. Add slicer to this page. Okay. Alright, so it appears as the multiple value slicer as we had as we encountered with the pressure rise just now. So again, I'm just gonna switch it to a single value slicer. Alright, so I'm just gonna make it bigger, make it the same size as the top one. And this one, the slicer, you can just basically adjust it again. Let's say I want a 200 meter cubes of tank, so I'm just gonna put it there. Tank. So now we have our second item, the two variables, which is the pressure rise or the final nitrogen pressure, and also the tank volume, which is the volume of the tank. So now that we have these two variables, we can proceed with the calculation, which is how much nitrogen is required to fill this tank. So now we're going to use the measure function. So you can pick either of these two, either pressurize or tank volume. So just click on it. In this case, I'm just going to choose pressurize, click, and I'm going to go to new measure. Okay, once you've pressed that new measure, you're going to have this. So this new variable. So for this new variable, I'm just going to name it as volume of nitrogen required. So I'm going to edit it a little bit. Volume of nitrogen required meter cubes. So this measure is basically quite similar to Excel functions. You have a few keywords, you can insert some simple formulas. So yeah, it's basically just the same as Excel. So in this case, we're going to have to put in some formulas. So if you remember from the Excel that I showed you, basically the formula that we're going to use is this one, which is V1, the volume of nitrogen, is going to be the value of P2, which is our pressure rise, times with V2, our volume of tank, over P1, which is, if the nitrogen is at normal conditions, it's just going to be 1.01 bar absolute, roughly. So we're going to put that in our measure formula. Okay, So this one, if you remember, once we've drawn all these two parameters, pressure rise bar absolute, and also tank volume. Oh, let me illustrate that. Sorry. Okay, so if you notice, um, let's say for this pressure rise, let's go to its field. We have this pressure rise stored in column, and also pressure rise bar absolute value, which is stored as a measure, or this calculator symbol. So what this really means is that all those large all those collection of values from 0 to 20 bar absolute that we have just now, with the increments of 0.1, is back under here, this column. While this one, this calculator symbol or measure pressurized bar absolute value, is the single value that we've already specified here. So that means this one is a collection of values, while this one is just a single value. So this single value would be whatever that we've put inside here. So that means currently, if this is at 5, this one will be at a value of 5. So the difference is this one, a collection of values, this one, a single value based on our input. So for our formula, I need to call out this specific single unit that I put in here. So I'm just going to go back to this measure formula that I showed you, and I'm just going to call that by typing pressure rise. See, it automatically pops out. Enter that. So this is our P2. So times with our tank volume. So the same concept applies. This one is a collection of tank volumes that we from the list of drop down that we saw just now. This would be the single value for the tank volume, which in this case would be at a 200. Okay, so I'm just gonna call that. I'm just gonna call this single tank volume meter cubic value. So I'm just gonna type tank volume. Alright, click on it. Now, if you remember just now that we have to divide it with the supply pressure of nitrogen, so because it is at 1.01 bar absolute, so we're just gonna put 1.01. Okay. Okay, now that that formula is done, so we're gonna illustrate that using a card. So you would have to go to this visualizations here and pick this. It's called a card. Click on it. So I'm just gonna drag it here. Okay, I'm just gonna adjust the size. So under the fields, I'm gonna drag this volume of nitrogen required, the one that I edited the formula just now. So I'm just gonna drag it and put it in there. Okay, as you can see, Power BI has calculated the value based on the formula that we put just now. So how do we interpret this? So basically, if I were to supply nitrogen at normal conditions, which is nitrogen at 1.01 bar absolute and a temperature of 20 degrees Celsius, with a tank volume of 200 cubic meters, in order to achieve a pressure rise of 5 bar absolute, I would be requiring 990.10 volumes of nitrogen. So now that I have this slicer, I can easily just adjust it and the value will change accordingly. So let's say if we were to change this to 1.2, so Power BI has automatically adjusted. So if I change it here, let's say I make it a bigger volume, voila, the value has automatically changed. So this one would be an easier way to illustrate. So whenever you want to calculate, you don't really have to, input all these things in Excel. You can just adjust your slicer and it will just show you the value that you require. So you can basically just play around with this, just share it with, people who would require to calculate these on a daily basis, and it would be an easier platform for them to calculate. So that's all for this time. So I hope that was meaningful to you. If yeah, this can seem before I end this video, I gotta say that this could be quite complicated at first, but if you really master, you have a basic knowledge of Power BI, like understanding the new measure function, new parameters function, it wouldn't be too complicated on your side. So yeah, I hope this was useful to you. If you have any questions, you may just drop a comment on my video. So look forward to uploading more videos in the future. Let me know of your thoughts, anything that I can improve. So, all right, have a good day.